16. Let f of x equal x squared minus 4, g of x equal x squared plus 4, h of x equal x plus 5. Without a calculator, match the functions a through f to the descriptions I through the I. Some of the functions may match none of the descriptions. Okay, so instead of trying to look at one of these and decide which of these is appropriate or the other way around, I'm just going to encourage you to find the zeros and vertical asymptotes and horizontal asymptotes for all of the functions in this list. So let's try the first one here, f of x divided by g of x. So first let's write what that function is down here. So f of x is x squared minus 4 divided by g of x squared plus 4. Okay, first thing is zeros. We know that zeros happen when the numerator is equal to 0. So we need to figure out when x squared minus 4 is 0. And if you want, you can factor that or add 4 to both sides. However you do it, hopefully you get plus or minus 2. So those are our zeros. Vertical asymptotes happen when the denominator is 0. So in this case, we're trying to figure out what makes x squared plus 4 equal to 0. And there's no real number that does that. So in this case, there are no vertical asymptotes. Horizontal asymptotes is where we have to look at the degree on top and the degree on the bottom. In this case, it's the same. And whenever it's the same, we need to look at the quotient of coefficients. So they're invisible ones in front of these guys. So the horizontal asymptote happens at 1 divided by 1, which is just 1. But I really don't want you to put the horizontal asymptote as 1. I want an equation. The equation of any horizontal line is y equals. So those are our answers for part A. And then in a little while after we get all these parts up here, we can then run through and try to match them up with the descriptions in parts 1 through 8. So if this seems reasonable, like a nice way to organize and collect your thoughts, then maybe pause the video here and then come back in a while after you've done this for parts A through H. And but we're just going to do them all together as soon as you come back. Okay, moving on to part B, g over f, x squared plus 4 over x squared minus 4. Zeros, when is the top equal to 0? Never. So there are no zeros. Vertical asymptotes, when is the bottom equal to 0? That happens at x equals 2 and x equals negative 2. Notice it's not just numbers, but it's equations of lines. And then the horizontal asymptote, same as before, look at the quotient of coefficients because the degrees are the same. It's still 1 divided by 1, so the horizontal asymptote is also y equals 1. Technically, yes, these two are the same number, but really it should be 1 is the reciprocal of the other. But it's kind of a coincidence that 1 is the reciprocal of 1. They're not always the same, just when you flip over the two numbers, or when you flip over the two polynomials. Part C, h over f. Okay, so upstairs is x plus 5, downstairs is x squared minus 4. So the zeros happen when the top is 0. That's at x equals negative 5. Vertical asymptotes are when the bottom is 0. That's at plus or minus 2. Horizontal asymptote, this one's different. So here the higher power is downstairs, which means the bottom is going to infinity a lot faster than the top. So the bottom is going to win, and eventually the whole fraction approaches 0. So y equals 0 is the horizontal asymptote there. Part D requires a little bit of work before we jump in. So part D wants us to think of f of 1 over x. So we're just going to plug in 1 over x right here. So when we do that, we get 1 over x squared, subtract 4. That's not really in a useful form. I want it to look like all of our other rational functions, so I just want it to be one fraction. So first we'll square top and bottom of that fraction and get this. And then we'll make a lowest common denominator so we can subtract, and we get 1 minus 4x squared over x squared. I think that's the most useful form to have this thing in. The zeros happen when the top is equal to 0. So we're looking for places where 1 minus 4x squared is 0, or 1 is 4x squared, or x squared is a quarter. Square root of both sides. We get x is a half. but don't forget plus or minus when you take that square root. So the zeros here are at plus or minus half. Vertical asymptotes happen when the bottom is 0. That's only at x equals 0. Horizontal asymptotes, look at the highest power. It's a 2 in both. It's the same, which means the quotient of coefficients. This 1 right here, even though it's the first term, it's not the leading term. So the leading term might be buried. It's kind of a misnomer. But the quotient of coefficients looks like it's a -4 over +1, so it's just -4. Okay, moving on to part E. Part E is g over h. So g over h is x squared plus 4 divided by x plus 5. So in this case, zeros happen when the top is 0. This top is never 0. Vertical asymptotes are when the bottom is 0. That happens at x equals -5. Horizontal asymptotes, higher power is upstairs, and that was one of our 3 cases. If the higher power is upstairs, there are no horizontal asymptotes. F. F is h of x squared over h of x. So we'll put the bottom first. That's just h of x. The top is h of x squared. So instead of the x we wrote down there, we're going to put x squared. Okay, so zeros are when the top is 0, x squared plus 5, it's a positive number, x squared plus 5, so it's never 0. Vertical asymptotes are when the bottom is 0. Horizontal asymptote, again, look at the highest power, it's upstairs. And whenever the highest power is upstairs, there are no horizontal asymptotes. G is the function 1 over g of x, 1 divided by x squared plus 4. Okay, first one is intercepts. When is the top equal to 0? Well, it's 1, it's never 0, so there are none. Vertical asymptotes, when is the bottom 0? Never, x squared plus 4 is always positive. And then for the horizontal asymptotes, the highest power is downstairs. Whenever that happens, the thing approaches the x-axis. So y equals 0 is the horizontal asymptote. Okay, and then finally h, which is f of x times g of x, x squared minus 4 times x squared plus 4. It's fine to distribute, but distributing is often not as nice as factored form. So I'm just going to leave it like it is. But I will put a fraction just so that it looks like all the other ones we've been doing. Okay, zeros happen when the top is 0. This thing right here is never 0. This thing is 0 at x equals plus or minus 2. Vertical asymptotes happen when the bottom is 0. It's never 0. It's always 1. Horizontal asymptotes, well, let's see. The highest power upstairs, you have to distribute in your mind. So even without doing the FOIL, you can see that the highest power is going to be 4. Downstairs, the highest power is 0. Whenever the highest power is upstairs, there are no horizontal asymptotes. Okay, so we've got our answers written in there, which means that now it's just a matter of matching up the descriptions on the left to what we found on the right. So if you haven't done that yet, maybe pause now that you've got all this good information and see if you can match the functions a through h with the descriptions, parts I through VIII, and come back when you're ready. Okay, so if you're back, I'll just tell you what I found. I found that part I here matched function in C. Part II matched both E and F. I didn't find anything to match 3 or 4. For 5, I found that that matched part A. 6 didn't have any matches. 7 looked like part D. and 8 didn't have any matches. All right, moving on to number 38. A woman opens a bank account with an initial deposit of $1,000. At the end of each year thereafter, she deposits an additional $1,000. The account earns 6% annual interest compounded annually. Complete table 1122. Okay, so the idea here is that you put in $1,000, you deposit $1,000 at the end of the year, you get interest on the money that was there at the start of the year. In this case, $60 makes sense because it's 6% of 1,000, not of 2,000, just the money that was there the whole year. That's your 60 plus the 1,000 that you put in, and all together the sum of those three numbers is 2,060. And now the interest is up here at 123.60 because it's on a much bigger number, and our job is to fill in the rest of this. So let's show you the standard way and then the clever way. So standard way is to say, okay, we're going to take 1,000 and multiply it by 0.06 to find the interest, $60, that's there, and then we add 1,000 to that number plus the 1,000 that we started with, and we get the 2,060. And then we'll multiply that by 0.06, and that 123.6 agrees here. We can then add the 2,060 plus the 1,000 and end up with the 3183.60, and then we can repeat. So the first blank is going to have this number right here, 191.016. But the clever way to do this is something like as follows. I'm going to type in 1,000 and just hit enter. Seems kind of silly, but bear with me. Here's the basic plan. We're going to take the 6% interest and multiply it by the principal. So we're going to do the previous answer times 0.06. But then we're going to add the previous answer, and then we're going to add another $1,000 on top of that. And so that jumps us right to the 2,060. But the nice thing is if I hit enter now, 2,060 is the new previous answer. And if we hit enter, it jumps us right to this very next problem. And if I hit enter, that's what goes in the third row, fourth row, and fifth row. So let's just copy these numbers here. Okay, so filling in the blanks with the numbers that we just found. So here in number 3, 4374 and change. And if you want to find the interest, well, you can just subtract the numbers in the first column here, the start of your balance. And so I'll fill in the numbers here. Okay, and then taking a look at the next part, it says, does the balance grow linearly, exponentially, or neither? Okay, so we've got this table of values. Essentially, we're just looking at the first couple of columns here. We want to know if that's a straight line or an exponential function or neither. Okay, so to figure out if it's a straight line, I guess what we need to do is calculate some slopes. So you can calculate slopes of these first 2 points. Let's circle them here. So if you find the slope of the line connecting those 2 points, and then compare it to the slope of the line connecting these 2 points, I think you will see that they are different numbers. And if it was a straight line, they'd be the same number. So you can pause the video and do that calculation and come back. But as soon as you get 2 different slopes, you can know definitively this is not linear growth, but maybe exponential. So one thing we discovered about exponential functions is that they kept increasing by the same percentage every step of the way. So to find the percent increase, or I guess they kept going up by the same multiple every time. So for example, if you did 2060 divided by 1,000. You'd get some multiplier there. And you'd want to compare that to 3183.6 divided by 2060. So the same kind of idea with those two pairs that I circled, but instead of subtracting to think about slopes, you can just divide them, like making a ratio table like in that first project. And as soon as you get two different numbers here, you can know that it is not exponential because it's not a constant ratio. So this setup actually has some linear part, but it also has some exponential part. And in the end, it's not either one. The linear part is continuing to add 1,000 each year. The exponential part is multiplying by the 6% interest, but doing the two of them together, adding 1,000, but also getting the 6% interest, makes it not linear and not exponential.